Okay, here we have a skier skiing down the slopes, and at an initial point in time, it is determined that the skier has 5,000 joules of potential energy, which is energy due to his physical height. And because he's in motion, he also has kinetic energy, and it turns out that that's also 5,000 joules, energy of motion. Now he finishes sliding down the hill, and he reaches some final location where he's got a good amount of speed. And at that point in time, his potential energy has dropped to 3,000. And his kinetic energy remains unknown at this point. Now, question A. Since they slid down the hill, what do you expect for the change in potential energy? Well, change in anything is always final minus initial. So it's EP final minus EP initial. And my final potential energy was 3,000. And my initial potential energy was 5,000. So that creates a negative change in energy, which makes sense. He's got lower on the mountain, which should mean he's losing potential energy. Okay, if you lose height, you lose potential energy. Now we know that energy is always conserved. So even though he's losing potential, he must be gaining something else to conserve energy. So let's look at part B. Now part B says, assuming that there's no losses due to friction, what would the kinetic energy be in the second location? Well, energy must be conserved, which means my total energy before, and I'll call that E total initial, has to equal my total energy after, which I'll call E total final. Now my total energy before was simply potential and kinetic, my two initial values. And my total energy after, since we're not producing any heat, is also still potential and kinetic, but we'll call these our final values. And if we quickly work it out, we had 5,000 joules of potential and 5,000 joules of kinetic before. And at the final location, he had 3,000 joules of potential, and I've got to figure out how much kinetic. Very simple math. If I've got 10,000 joules on the left, I need 10,000 joules on the right. So my kinetic energy must have increased to 7,000 joules. Which makes sense. If he's falling in the absence of friction, he would be picking up speed, which means your kinetic energy is getting larger. Now part C. Since there's always some frictional loss, what would the actual kinetic energy be? Would it be more or less than 7,000 joules? Well, if we go back to our conservation equation, if there's friction, we would also be producing heat. Now I'll do this in blue so we keep track. So at the end here, I've got kinetic energy and I'm producing thermal energy, which is energy due to heat from the rubbing between the skis and the snow. Now, if I'm producing an extra amount of energy, that leaves less left over for kinetic. So your final kinetic energy would be lower because I'm losing some energy in a sense to heat. So CEK would be less, in fact, than 7,000. So as he's skiing down, you can think of it this way, he's losing energy to heat. Something's being generated there, leaving less left over for the final EP and EK.